Good to see you all still around. Hopefully enjoying the conference. Also funny that you're like still, this is the last session and we're going to talk about security. I'm going to be focusing on supply chain security in general and mostly .NET supply chain security. First, it's always a good thing to politely introduce yourself with a really big picture next to it. So my name is Niels Tanis and I work as a security researcher for Vercode. And I got a background in .NET development. Started out my development career with the first bits in the early 2000s and then moved on to security space. Did some security consultancy, ethical hacking, pen testing, which is a lot of fun if you are allowed to break into systems. But I think the key still lies in the fact that we need to build better software. We need to build better and more secure systems. And that's exactly the reason why I'm standing here in front of you to talk about this topic, supply chain. We also do a lot of stuff with static analysis, .NET. If you want to talk more about Vercode, come see me afterwards. There's also one disclaimer. I'm going to mention the company once more. You're going to see the logo all the time because it's on the slides. But I'm going to mention it once more, and that's going to be it. And as I said, come see me afterwards if we need to talk about this. I've also done a series of these talks in the past, so you probably will recognize some of the concepts. Concepts do not change, but companies have made some good movement in that space, and that's exactly what I want to touch. So first, to define a bit of a story field, what we're going to look into. So when I started out my development, it was mostly monolithic applications that are being deployed on a single machine. You just hand over the MSI to the IT pro that was responsible within the organization that would install it. Everybody could use it, right? Pretty straightforward from something that's been written, software, then to deployment. And if we then take a big leap forward and look at how we do stuff nowadays, it's totally different, right? It's much more fine-grained. It's maybe even cloud native. You're hopefully like doing some continuous integration, continuous deployment, that kind of things. We're all not Facebook, but there must be a quicker pace compared to what I did at the beginning. And with all of that comes a lot more code, a lot more automation, a lot more stuff that's involved, and also a lot of more steps in order to be our, let's say, supply chain from code to something that we deploy. And that's the supply chain, right? So in order to have a definition of how I'm going to use supply chain, we're going to quickly look into that a bit. We're also going to look into some analogies and other industries that allow us to tell the story. Then we're going to dig into securing the supply chain itself. We're going to look into what developers need to do with source code, how they interact with source code. Then, of course, third-party libraries, big importance if you look at it from security perspective. We're going to touch on that. And then the end, build and release. We need to build and deploy and distribute our software across our, let's say, consumers or within our organizations. That's the last bit. And there's going to be conclusion and QA at the end. What is the supply chain? The analogy I always use is automotive car manufacturing, because at some point in time there's a lump of steel that enters the factory. A customer has ordered a car with specs, and then across the factory line it will get parts added and value will be added and stuff will be added to the thing, right? So on average, a car will have 10,000 parts along the way, and those are all being created by 2,700 different suppliers, right? So keep in mind, if you buy a specific brand of car, then 2,700 different vendors will have also supplied parts for that car in order to have that end product of that car rolling off the factory train. Automotive has also solved some of the issues we're going to look into in a pretty good way. If we then take a step and say, like, hey, what's our supply chain? And this is my abstract view of the supply chain I want to talk about today. It's source to deployable artifact, right? Which probably can be a package that you're going to release to some repo, or it's maybe a Docker image that you put in some registry that you can deploy yourself, and everything that's in between, right? So there's a developer that will interact with source code. We have some third-party libraries because as a developer, we want to reuse what's already there, right? Why would you want to reinvent the wheel yourself over and over again? There's going to be some build stuff, and I've used the GitHub Actions here, but this is, of course, interchangeable with every system that you're using, right? Which is GitLab. If you're doing OpenShift, that's all fine. You can all have similar blocks within this thing. And at the top, you see something called Q&A. I'm all assuming that you probably do something with Q&A testing, hopefully also security, right? Otherwise, that might be a problem. But these are the steps of the supply chain from source to deployable artifact. And what could possibly go wrong? And I'm not sure if some of you already was in the talk that Mike Martin did in the room next to this, before this slot. He mentioned SolarWinds. And SolarWinds, I think, is the biggest example within the supply chain, let's say, history of an attack that happened. Turned out that the build server was compromised in a persistent way, and malicious users could like add stuff to the SolarWinds products that were then being built and then shipped. And to make it even more like looking that nothing happened, all the packages were signed. You could not see it unless you look into the software itself. And I think also if you look at security in general, these types of products have become a bigger target, right? If it's monitoring software, in case of SolarWinds, that gets installed across organizations in a broad fashion, a lot of machines will have it. And if you're maturing with, let's say, your security infrastructure and the infrastructure has been locked down, then attackers will probably want to have another way. And this is of course a really good way to get a big hack done if you have access to those systems, right? So this CrowdStrike article talks about how they implemented the build process. There's also a link in the notes of the slides that talks about the Microsoft link that also Mike showed, which talks more about how the internals worked and what was the communication that it did. If I'm referring to slides and if I'm referring to links, they're all in the notes. At the end, I have a GitHub repo which contains everything, so you can find it over there. So another thing is also, this is a cartoon that I need to include with literally every presentation that I'm doing. So this is the XKDC, which you probably all have seen in other security talks with Jimmy drop tables, right? That's the other one about SQL injection, but this one is called dependency. And I think this illustrates the problem pretty well. It is called modern digital infrastructure, but you can just replace it with application architecture or whatever. And there's somewhere at the bottom, there's a project some random person in Nebraska has been thanklessly maintaining since 2003, right? So there's a small bit in your software supply chain, which of course is being maintained by somebody, but if that single block gets altered or changed or flips over, then the whole pile will tilt, right? It will just be gone, maybe. So this illustrates the problem that we're having. And what's the first space we're going to look into? As I said, developer and code. And in order for a developer to interact with a code, let's say repo or something else, it needs to have authentication. Authentication involves credentials. And what happens with credentials? Credentials get stolen. And this is an article that was published in 2019, which talks about the canonical GitHub account being stolen, right? And the canonical, those are the people behind Ubuntu. And I'm using some build demos at the end, which I'm sharing with you, and you will probably see those build images are all based on Ubuntu. So if you have access to these repos and you can alter the Linux distribution, then it's quite powerful as well, right? So this was just ordinary credential theft. I believe that was the case. So what can you do in order to do a better job with credentials is use multi-factor authentication. That can be OTP codes or maybe a hardware token, a YubiKey or something else. Fingerprint reader in your machine, I don't know, there's a lot of options, but make sure that there's an additional factor. It's not only relying on username and password, because if they get stolen, then the additional factor probably will help you out and not having that thing compromised. And if we now look at Git and Git system in general, there's an additional factor you can use, which is called Git Commit Signing. So I'm not sure if you're familiar with signing, Git signing, but you have a private and public key pair, a GPG key pair. And in order to commit your changes, you will sign your commit with your private key, which you always keep close to yourself, and then publish the public key, in this case with GitHub, which will then show up as a nice green verified box, as if you look into the source tree. What does this give us? Totally nothing. But it gives us an indication that I, or at least it was Niels Tanis who checked in this code, I have access to this account, and I also have that private key, right? So if my credentials or even the complete account gets stolen, people probably don't have my private key to their disposal. So this can be let's say an indicator of compromise. If you always work with signed commits, then this might be a good indicator for that thing. What else could go wrong? Something called Hypocrite Commits. So this is a university in Minnesota which did a bit of research, and what they eventually did is they joined some Linux, I think, kernel project, and they were able to eventually become malicious, at least like as a test. They social engineered their way into it. They made some contributions to the kernel, and then eventually they were able to commit some code which was malicious, in order to show like, hey, this is how fragile it is, right? If you depend on still people that do work, you can probably imagine that the people who are involved were not amused about this. I can also get that. But it's still a way to do this, right? And who knows, like if you trust people, then this will still happen, and that's just a matter because it's people doing work. In order to interact with source, what do we need? An IDE. And what happens with IDEs? IDEs get hacked as well. And in this case, it's a small sidestep. It's about a Java IDE, NetBrains, which can be used to build Java applications, and it turned out it had some malware inside of it. You could question yourself, like, hey, what's the means? Why would somebody do this? Maybe mingle source code before it gets checked in, or maybe use the compute of the development machine for something else, or use the developer machine to get, let's say, across infrastructure within organizations. There are several stories, right? But stuff happens. And if we then look at IDEs itself, I'm a big user of VS Code. I do a lot of things, like I'm not only doing .NET, I also program in Rust lately a bit. So if you grab VS Code, you can just grab the extensions, you can just use it all along. And VS Code itself is based on Electron. And what you see over here, I'm not sure if it's completely visible, but this is the dependency graph of Electron, an Electron system and all the libraries it relies on. You can generate that. And if we see over here, there's like 82 dependencies, right? So Electron is a single thing, but underneath there, there's transitive dependencies, which totally adds up to 82. These 82 dependencies are being maintained by 110 people. So 110 people touch that code that ends up in Electron, that ends up in VS Code, that also ends up in Slack. It's also Electron-based, right? So a lot of hands that touch it. And these are only the maintainers. You can multiply it by 10, and those are the amount of contributors that also help out. So a lot of people touching code that eventually ends up on your desktop to run, which of course can be a risk. And what happens with IDEs itself? Vulnerabilities get found as well. This is a remote code execution that was targeting VS Code, which was, I think, published in May, so a month ago. Stuff happens, right? We need to update it. And VS Code itself also has a supply chain. And this was 2021, when this was published. And it turned out that the way that VS Code deals with issues, there's a nightly build script that gets executed. And for some reason, the inputs were not properly sanitized. And in this case, it was a bug bounty person who figured that one out. And he was able to commit code to the release branch of VS Code. And he even got a lot of money for this, right? This is a bug bounty. He disclosed it with Microsoft, and it was undisclosed. So I'm sure it's probably a lot of money he got out of it. But keep in mind that this is all part of the IDE, all touches it, right? And therefore we need to make sure that we keep our tools up to date and make sure that we keep that in mind. I think that's the conclusion. Moving on, libraries. If we develop, and I do it myself, I want to build stuff on top of stuff that's already done by others because it helps out. I don't want to solve the problem myself, right? I'm lazy to that degree. What happens with libraries once they get added to a project? It turns out, and this is the only Veracode slide I'm going to show you, that 79% of the libraries never get updated once they're added to a project. And this is a problem. So this is a state of software security which shows some metrics, and this is the edition of last year. But it gives us a good insight of these kinds of things happen, right? And what happened with libraries? Libraries have vulnerabilities inside of it, right? And in this case, it's something that was published and related to .NET, remote code execution. And this was in March of this year, right? So there definitely is a need to upload those libraries. And if like 79% of people are not doing it, that's a big of a problem. What else happens with libraries? Libraries get malicious code added. And this is the one that was related to an NPM package called UA parser, which parses user agent strings. And I believe it targeted Bitcoin wallets and crypto wallets. And why was this done? How was this done? Credentials were stolen. And in this case, GitHub, because NPM of course is part of GitHub, they want maintainers to have multi-factor authentication turned on, because that makes sense, right? But it was pretty straightforward. You can imagine that if you have a small package that's used across a lot of things, we've seen that with event stream in the past as well, you can get a lot of leverage, and that's quite powerful. What else can be happening with dependencies? We can get confused, or something called dependency confusion. In this case, it's a concept where, let's say, NuGet, you have a private NuGet repo within the organization where you have your own packages that is like the baseline of the .NET apps that you're writing. And all those packages have an identifier. and those are private to your organization. What if that identifier is used on a package that also is publicly available on NuGet.org? Then the package manager might get confused, right? And that's exactly what the concept is, right? It might get another version expected and instead of the private one you want to use. This once again is the person who wrote this blog post also had bug bounties from Apple, Microsoft, and other companies based on this, and pretty significant, made some money out of it. But this is a problem, and this can be like every package system that has some identifier component to it has this kind of an issue. The question is, what can we do? And there's a really good white paper from Microsoft that talks about the 3 ways to mitigate risks when using private package feeds, which is totally about dependency confusion and what you can do against this. The link is in the slide, but like a summary is, if you can rely on a single private repo, that's the best because it gives you control, but I'm not sure if that's workable, right? So maybe use something like Azure Artifacts or Artifactory or whatever, like a centralized system that allows you to control any upstream packages that are like being fetched, that you at least know what will be fetched when. If you have a company that has a prefix of packages, you can go to NuGet and get it registered as a prefix that you're only allowed to use, which is the checkbox you see in NuGet sometimes behind the name. If you go to Newton, Soft JSON, you see that name, that prefix is registered, right? Same for Microsoft. So somebody else cannot like publish a package that is called Microsoft.something. And maybe you can be more rigorous and say like, hey, I want to log packages in or log files saying like, you're only allowed to use this. So, and the white paper contains a lot more about on how you can do it with NPM. Also, if you're more like Java, Maven, there's some really good content in that white paper. Go check it out. What happens also if you use libraries, and that's also one thing I've talked about in the past, is if you pull in third-party libraries, always be aware of what's inside. What's the intent of the library? Keep in mind that you never get a single package. It's always maybe a transitive tree of stuff you get with it, right? Because it maybe relies on some crypto libraries that needs to be included. And for that matter, I think there's at least developers need to have a sense of like, hey, if I have this PDF generating library, why does it need to have access to some cryptography library? Why is that? And maybe that's because it needs to sign PDFs, right? That makes sense. But it's always good to have some idea about that. If you want to do more risk reduction on that, I did a talk on sandboxing.NET assemblies at Energy Portal, which you can find online, and the link is in the slide. But I think there's also a real good other project I want you to look into, which is security scorecards by the Open Source Security Foundation, or the OpenSSF, which is also part of the Linux Foundation. And you can see security scorecards as being the nutrition label on your food, because it describes on what's inside. Some health metrics, right? So you can find the full spec on what it is on that GitHub repo. But there's also some cool projects, and one of them is DepsDev by Google. And they consume the data, or at least they register the security scorecards of different components, different ecosystems. Unfortunately, NuGet has been coming soon already for the last almost 2 years, I guess. So I'm not sure how much it is. I think it's just incubation. Hopefully this lands somewhere and becomes a full-fledged thing. But you can look into packages and you can see how good the security is for that package. And if we then take Electron, so the one that we looked in before, when we looked into VS Code, you can find that there's some score being done, and the total score is 5.8 out of 10, which is a moi, right? High school, this will be sufficient for me, 5.8, right? It's okay. And then on the right-hand side, you can see all the different aspects of what they've done, right? So there's no signing of releases, there's no sign of them doing any fuzz testing, which is like hammering the component with input and see if it crashes. But they do have a good security policy in place, and they also have some CII best practices implemented. So you can find the details, but it at least gives you some sense of like, hey, this library, how good is it? Let me look up the metrics and see what kind of stuff they are doing. What else is a factor? If we look at .NET in general, there is, of course, since I think it was .NET 6, it was fully released, right? The source generators. And when looking into source generators, I was discussing it with my colleague Matthias, who wrote this article, and he says like, hey, source generators can be a real good target for supply chain attacks, because keep in mind that a source generator can be part of any project that you just include and will be done at compile time and will emit files. So what if you do that inside of a package and nobody knows, right? A developer hopefully knows what's inside, but if there's a source generation done, you can inject malicious code. And he wrote a whole blog post on what you could do, and he has a POC where he shows what the capabilities are, right? Which of course is extensively, you can just do a lot. But the fact that it's inside the project makes you think like, hey, is it needed, right? Source generation, less reflection, better performant code, it totally makes sense. But be aware like when it's used and when and by which project. You could technically turn it off. This is a snippet which is quite rigorous. It will turn off all the analyzers for all the projects. This is probably not what you want, but you can be more granular, saying like, hey, I want to only run this analyzers for this project, and that's it, right? So keep in mind source generators, something to look into. What else is important? And I think if you look at third-party libraries, and if you go to a GitHub repo and look at its source code, you should be able to build that library in exactly the same way you get it from that, let's say, NuGet or NPM or whatever you're relying on. And in order to do that, we need to have something which is called reproducible builds, right? So grabbing source code and building a binary which exactly matches the thing that you're using. Because otherwise, how do we have a guarantee that that library that you're getting from NuGet is built with that source code, or maybe mingled, or maybe there was a source generator in the build pipeline that added some code that we do not expect to be there, right? There are a lot of things. And this is important. Luckily, Roslyn, since version 1.1, has some kind of deterministic behavior, how it works. Given inputs, it will produce the same outputs, but that also relies a bit on like build servers and stuff, how it's configured. But there's a real good Roslyn design document that you can find. Deterministic inputs, that's how it's called. And then a quick question, and I'm just gonna like, this normally will be a demo, but I just want to have like a quick question and answer from you. If I create a console app in .NET 6, default console app, and I call it app for Emitter, and then I build it, and then I copy that folder to app2, contains the same contents, and I build that one as well, fully rebuilt. Who thinks that those DLLs, so let's say you've got app DLL and app DLL, they're exactly named the same, are exactly similar inside? Who thinks they're the same? Okay, and the rest probably thinks the otherwise or doesn't want to give an answer, which is fine. They're not the same. And that's because of some PDB and debug information, right? Because it was a debug build. You also could have answered like, maybe depends, Niels, on the configuration. Yes, that's true. But there are some flags that will change the PE header, so you cannot bit by bit like compare a DLL saying that they're exactly the same. Logically inside, what's inside? They will be the same, but the fact that you cannot like change, like really compare it at the file level, that makes it hard. So if you're doing .NET, please look into a package which is created. So fix a third-party library with something that you need an additional library as well, right? So reproducible NuGet package, which will configure continuous integration on build, and it will also do source link, right? That will take care of pointing out to a GitHub repo and allowing people to debug. And there's also a .isolated version of that package that also looks into hermetic builds, which is another thing, because if you build a package, you don't want it to get like third-party libraries from literally everywhere. You want to have more control over where it gets, right? And that's exactly what that other package does. And also within the .NET NuGet team, there's a good design made, and unfortunately it's still a design. I'm not aware of it being implemented right now, but they want to have a way of validating these kinds of things, right? So if you're doing deterministic and reproducible builds on the way that it was configured, as I showed this slide before, then hopefully in the future there will be a .NET Validate CLI tool that allows you to validate against, this is the source, is it a reproducible build, and does it match what I'm seeing here, right? So this is a really good step forward, because this gives us insights of this source is being used in this binary, and I can also validate this. So with that said, we're talking about builds. What else do we need to do with artifacts once we build? Assign artifacts. And luckily, within the whole ecosystem, this is also a Linux Foundation project called SigStore, allows you to sign packages for free with a certificate. And SigStore has the goal to become the Let's Script from software signing. That's their goal. And it allows you to get a certificate, and it has a whole like system behind it, which is in this slide, but I'm not going to fully explain it. But the key lies in the fact that there is a transparency log where certificates get published, and the signing certificate you get is a short-lived one that is just enough time window for you to sign a package, and then you can allow others to validate. So this is a really good step forward, right? For the same way that Let's Script has given a TLS on a lot of websites, doesn't give us any guarantee for the same reason that signing packages doesn't give us any guarantee, as we've seen with SolarWinds. But it is a good step forward. And the good thing is that with Sigstore, they also released a project called CoSign. And CoSign can be used to do signing of Docker containers, Docker images, with Sigstore. And the funny thing is that it can also do keyless signing. So normally you can generate keys and store it, but then you need to deal with secrets, which can be hard. And if you have OpenID Connect, you can just like do the OICD flow where you just sign in to an authentication provider and then get a certificate with your, let's say, authentication credentials inside and sign an artifact. And that's enough evidence for me. Let's say if I do cosign at the CLI level and I have a Docker image, I log into my, let's say, Google, Gmail, and then if you look into the certificate, you will say like, hey, Niels Tanis signed this Docker container at that time. And that gives them some guarantee because at that time I was the only person that had access to my account. And I could sign a container. So that gives them a bit more of like, hey, this is the origin, this is the end result. I think this is pretty cool. And GitHub Actions has OpenID Connect support since last, like November, I think, 2021, which you can just use straight away. So this is cool. And if you then step back to the Git Commit Signing, a couple of weeks ago, somebody published a project that does the same with Sigstore behind it. So you can do Git Commit Signing as well with then going the OICD flow, which is quite powerful. Then eventually you don't get the verified box in GitHub, as I said, because you could question like, what's it worth? But it will give you the ability to do the additional fact. I think this is a good step forward as well. Leveraging things that are already there, and Sigstore is definitely the project to go for. Stepping back, so if we look at the stuff that we've done right now, which is all pretty pinpointing things within our build systems and the machines that we use, or tools that we have, the access that we have, what else do we need to do? And I'm going to take a big step, get back to the automotive industry and look into some of the ways how they've solved other problems that we're also facing. So I'm not sure if you're like an Autoweek reader, but I certainly did. And normally what they do is they take a car apart after 100,000 kilometers and they will show all the parts that are inside the car. So then they take this picture like, hey, it looks like this. But we all have been in a situation where we got a recall of our dealership or our, let's say, car manufacturer saying, hey, your car needs to go back because you need to have this part fixed. There was some malfunction with some, let's say, seatbelt stuff. We need to replace it because it's a risk. For some reason, they know exactly which part is inside your car, right? And how can they do that? And if we then hypothetically look at a supply chain, you could say like, hey, if we want to build disc brakes, we need to have steel. And steel originates from a factory, which is Tata Steel, right? Emuiden in the Netherlands. I don't know what has the origin. Then it goes to the Bosch factory that will make steel disc brakes out of it. And then they get added to a car, which might be used by different brands like Ford, Volkswagen, or Renault. And then at the end, we will have a car with a vehicle identification number and all the things that are being put into it, right? Hopefully, each of the steps also involve quality checking, right? So let's say the steel has some ISO certification and the disc brakes itself also have some checks done. And then at some point, the disc brakes, there is like a malfunction in, or they found the batch was wrong with steel. They communicated back to the Bosch factory, and then every disc that was used on different cars can be tracked back to the car, right? And that's all like the ledger you have. That's the thing. And that's the car is registry of all the elements that are inside. And can we do the same with software? And the answer is software bill of materials. That's how they call it nowadays, which is should be an industry standard for describing software. Who created it? What's the product, right? How can the project be used? Like, what are the licensing stuff? How is it created? What are the materials? There's a lot of things, and this is a document. If you go to the NTIA org website, you will find there's a really descriptive thing like what they wanted to achieve with this standard. If we want to be more practical and say like, hey, this is fun. How can we use this? One project is called Cyclone DX, which originates from OWASP. And what Cyclone DX does is it can generate a lightweight SBOM, that's how they call it, on dependencies that are inside your project. And it will have a graph that will have all transitive ones as well, right? So a big document that describes the software and describes what's inside. If you can do one thing and do a step forward, then this is definitely a good thing to do because it will give you an inventory of which components are used where, right? Similarly to the car as I just gave you for that example. So this is one. What else can we do? Luckily, as I said, the industry is moving forward. And if you now have the Docker CLI, I think it was the latest version, you can also do an SBOM generation of the Docker container at that point from the Docker CLI. And it's using Anchor Sift, and Anchor Sift has the ability to look into the file system of a Docker container and dissect what's inside. It recognizes the different project files. It also sees like, hey, this is a .NET app, so it has this dependency graph tied to it. So pretty powerful. You can do an SBOM generation as well. So cool, it's all landing into tools like Docker CLI. If you're using that, you can just easily integrate this. Another thing which has been around since the beginning, and I've played around with a lot, is something called Intodo. And Intodo is a framework for securing the integrity of software supply chains. And Intodo itself is pretty strict, and there's a lot of terminology which I'm not going to like fully bother you with right now, but it allows you to describe process and steps, people who are responsible, who are involved into the process, to how your software is built. And at other conferences, I've done a demo which end-to-end has a source file and then get manipulated. Then you can tripwire the source and you can just check it. And it all involves public-private key pairs, which need to be managed. So it's all pretty tedious if you want to work with it. So it's not as easy as, but for example, Datadog, you probably heard of that company. They use it for their updates in their agents in order to verify their software supply chain. There's a really good blog post, which you should read about that. And I also included some of the things I just mentioned. So within this notes, there is a link to a GitHub repo, which is my awesome web app demo. That's how it's called. I use GitHub Actions. I have an Intodo supply chain definition, and you see how I use it. I use Sigstore cosign to sign the Docker image because that's the end product. And I also generate a Docker SBOM with Sift. And also using the OpenID Connect flow in order to sign it, right? And I think the cool thing about this demo is that I'm not like totally sure Intodo is the right way, but I will get to that in the next couple of slides. But it gives you the guarantee to have a narrative like, hey, this is the source, this is how it's being built, and this is the end product. And you can correlate that chain, right? That supply chain. And I think that's really cool. But Intodo has been really strict. And I think that's also not like helps out with adaptive, like if people use it, right? If a tool is too complex, then it will be hard to use, and then you might have counter actions tied to it. Luckily, Google saw that, and they decided to create something which is called SLSA, and that stands for Supply Chain Levels of Software Artifacts, or SLSA, as the acronym is called. And it's a maturity model for you to go through supply chain risks. And if you look into the definition, they have like a whole standard document that describes this. The first thing you will see a trap model, and that is actually shows the developer workflow I just started out with. There are different levels, and provenance is something they use for, let's say, SBOM or proof of stuff that happened within your build pipeline. And they are like gratefully like showing you like, hey, if you do a hosted source build, which is like a GitHub Actions that's documented, you can generate files out of it. Then you're at level 2, and then level 3 is more controls, more involved into, let's say, you need to make sure that provenance is signed and that cannot be altered by the developer, for example. Non-falsifiable is how they call it. And then at the end, 4 is the highest level. And these things are all like, I think this is a good step forward, and it also allows you to integrate nicely with GitHub. Because what they did in April of this year, they released a GitHub Action that you can use. And there's a tool that allows you to do provenance level 2 easily. And they also have an example on where they show level 3 with Go binaries. And they have a trusted builder that they also verify against, like, hey, is this really the builder that also was released by the Go team that's responsible for doing that, right? So I think pretty cool. It uses hosted runners, which is of course like each job action within your workflow has its own VM, which isolates it. And they also have Sigstore keyless signing with OICD, and there's a verified include. If you're interested in doing this, I'm still, it's on my list to work out something similar for .NET, that we can just use it within the whole space and getting that level 3 and then 4. And it's also important that companies talk about this. And this was, I think, published 2 or 3 weeks ago by the SUSE team. And they explain exactly how they came up to level 4 with SLSA and how they've taken the steps to make sure that their builds are reproducible, that they sign all the SBOMs that they create with all the provenance that they want to show off. So this is a real good step forward. I also think if you're looking at this and saying like, hey Niels, this is all tied to GitHub and it's all maybe Google, I'm using GitLab. Luckily, GitLab has a tool, or at least like somebody else created a tool for GitLab, which is called Witness. Testify-Sec has done almost the same thing you saw with the SLSA action for GitHub, only it runs on GitLab, and it does the same. Each of the actions that are being performed in your build CI within GitLab will be provenance signed with Sigstore. And you will be able to produce the SBOMs, right? And it will just create a heavy load of documents, which is data, and that we, of course, need to use. That's the next step we're going to talk about. But this is cool. There is also something for GitLab. And if you're running OpenShift or Tekton, I would suggest you look into Tekton Chains, because that's doing exactly the same. You have that action level, like you have your build pipeline defined in OpenShift, and Tekton Chains will do the signing of provenance for each action that gets executed. Like, hey, this is the command, these were the environment variables, these files will touch, there's a lot of information and being signed, right? So also tied to that fact that at that moment, that build action resulted in these files. So there's a good end-to-end thing done. And when I started out talking about this, I mentioned SolarWinds. And SolarWinds also published their solution for the supply chain attack they had in the past. And last year at KubeCon, there also was, I think it was Cloud Native Security Con or Supply Chain Con. There's a lot of acronyms that they use nowadays. But they showed the project that they used in order to fix the problem. And I think this is pretty cool because that ties up all the things I just talked about. So let's say we have a build pipeline, and in this case, it's based on Tekton and Tekton Chains. They build the products, which eventually become a package that gets distributed to Amazon S3, or they have a container that will be pushed to Amazon ECR. And Tekton Chains itself will have each action of the build steps being published into a document database and then available. And this is just something that developers can use. They can just use it, they can alter it, they can use in a way that they want to, right? Because I think I'm a strong believer, if you do product security, then you should help out developers, just do their job in a good way possible, but give them some security constraints, but not be in the way of them. I think that's the key. And what they've done, and this is pretty cool, so this is the first step they do, they introduced a validation cluster next to it. And this is the same build pipeline. Only that build pipeline is being controlled by the people who are responsible for application security and have more knowledge of like what might go wrong. What needs to happen is that once source gets pushed and a build gets started by the normal cluster, the validation cluster will do exactly the same. And the provenance and all the SBOM and all the stuff that's produced needs to be matching with the other one. And they push it to a database. And now it gets funny because that database then allows you to enforce policies and saying like, hey, somebody added code or this DLL doesn't match in the validation cluster, so something went wrong. And then you can investigate further and hopefully figure out what happened, right? So this is Project Trebuchet, and if you want to see that presentation, the link is in the slides. But that was done by the person from SolarWinds who was responsible for fixing this. And I think this is pretty cool. That shows all the concepts I just touched working in a broader fashion. And the same counts for if you're working with OpenShift and IBM OpenShift. You can build stuff, and there's a whole zero trust approach, right? So there's no need to store anything, and based on the evidence and how stuff gets executed, it will build, in this case, on microservices, packaged container images. And this is all reference architecture, which was done by a person from IBM Red Hat, and he publishes it. And if we then look into the details, and this is a diagram that contains a lot of information, but we see all the same building blocks that I just talked about. It involves Tekton Chains. There is a Sigstore involved as well to sign stuff. And at the end, there's a Cavirno admission controller that enforces the policy of the things. And allowing you to look into the SBOM information and see like, hey, do I have signed containers with cosign? Because that can be a policy thing. Do I have all the SBOM stuff generated? Does it match? Do I have an SBOM that shows that security scanning has been done and no vulnerabilities or critical vulnerabilities are inside this project, right? You can be really granular. And I think this helps out taking that data and leveraging it, right? If we look at Google, And when I started out talking about this, which was 2019, they already had a project called Graphius in Cretus, which exactly does that, like being that centralized data store for all the elements. And Cretus is their like conditionally deployment that they use on the Google Cloud Platform. They have already done this since 2019. The projects, I think they touched, they published it also at the security conference and showed how it worked. I think this is pretty cool. They were already a real good step in the right direction, if I look back at it. If we look at the Azure ecosystem, then the only fit I see right now where it might come in is something with Azure Policy, where you enforce policy on enrolling stuff within Azure. I'm not sure if they're doing anything about it. I haven't seen it. If anybody of you know, like, hey, they're working on this, let me know. But I think this will be the building block they can go in. And there are also other companies started out. So there were a couple of people that worked on SigStore on SLSA, and they worked at Google, at IBM. They started out their own company in order to do this. And ChainGuard is a policy, cloud-native policy engine that allows you to do the same for your Kubernetes clusters. You can spin up ChainGuard, and you can have it evaluate policies before deploying new stuff. And attestations, and check at the SBOMs and say, hey, this is good or this is bad, and I don't want this to be enrolled. So with 2 minutes left, I'm going to conclude, and then I have a couple of minutes left for questions. So if you look at supply chain attacks in general, I think it's just not how, it's more a matter of when, right? Just assume that it will happen. I think it's important to be aware of like what type of supply chains you pull into your own project, right? Because a library that you use has its own supply chain, which get compromised, right? It can be really a maze and it can be complex. But I think the key is like know what you're pulling into projects and where you're using it, right? Look at Cyclone DX. If you can do those SBOMs by looking at dependencies, you're already a good step forward. Because I'm a security guy, I need to say you need to integrate security into your development lifecycle. It's not an afterthought. Also, as Mike said, you need to make sure that you put it in from the start. And as I showed you, like it would be cool if you can also generate SBOMs and work with that, and then maybe see if SLSA is a way for you to work. There's also an OWASP equivalent of doing this. That also has a more of a maturity model where you can look into and try to work with the SBOM output and use it, right? So with that said, I'm going to say thank you. The GitHub repo is over here. It's future tech within my GitHub itself. It has the slides. It also has the reproducible demo. I talked about those console apps you can just generate yourself. And it has the slides with the notes that has all the links. You can reach me out on my email or on my Twitter handle, and I'm going to be around for the next, I'm not sure like how long the conference will last, but I'm going to be around till the end. So thank you for your time, and hope to see you next time. Any questions?